Hi everyone, in this video I'm going to demonstrate some of the new features I have added to Telemetry Viewer. So here we have a balancing robot that I developed a while ago and I've shown in several videos, and this is the remote for it. You can drive it around, nothing particularly special, just a balancing robot. Here I have a old smartphone working as a network camera, and here I have a Flir E4 thermal camera working as a USB webcam, just propped up with a clamp to hold it in place. And I've added support for cameras to Telemetry Viewer. So we can see here, if I drive it around, yeah. And perhaps one of the most commonly requested features was support for the Raspberry Pi. And I have most of the features working on the Raspberry Pi 4, so I will also do a demonstration on that later on in the video. Alright, I'll start off by highlighting all of the new features that I have added to Telemetry Viewer. After I go through that, I'll do a demonstration of how to use everything from start to end, in case you haven't seen my earlier videos. And then after that, I will show how to use it on the Raspberry Pi 4 and cover some of the limitations that are related to OpenGL ES when running on the Raspberry Pi 4. So if you have used Telemetry Viewer before, the most obvious new feature is camera support. So here we have a thermal camera, my Flir E4, and I can go ahead and make that bigger. And you can see here we have the image that came from the camera. So if you're not familiar with the Flir E4, you can plug it into your computer with a micro USB cable, and then it acts like a webcam. And here we have the image data. So this particular robot isn't really a great demonstration of the thermal camera, but I think you get the idea of how this can be very useful. And then here I have my old smartphone, a Samsung Note 5, working as a network camera. And picture quality is not so good because I have the lights off now, but it is capable of decent video. And so as far as features and settings, if you click the gear icon, basically you have the camera types listed here. So it could be a Flir camera, or it could be whatever local cameras you have. It would be a USB webcam. If it's a laptop, any built-in cameras would be listed here. And then you'd have MJPEG over HTTP, which is the network camera protocol that I currently support. The features are very simple. When you're doing the MJPEG over HTTP, basically you don't get to pick a resolution or a frame rate or anything like that, because that all depends on the camera. And so you just have the ability to mirror and rotate. So I can mirror left and right, up and down, and rotate. If you want to rotate counterclockwise, just check all three, and that will have that effect. If you don't want the label, you can hide the label. With a webcam, like this Flir, then you can pick a resolution, and then the rest of the features are the same. The webcam library I use does not actually seem to support querying the allowed resolutions. So there are 4 hard-coded resolutions, and you can request whatever you want, and you just get the closest that the driver can give you. So my Flir E4 can only do 320 by 240. So even if I ask for 4K, I'll get 320 by 240. That pretty much sums up the camera feature. So I'll go ahead and remove the chart so you can see. So if you want to add a camera, you just click and drag, and then you pick the type is now a camera. And you can then pick one of your cameras here. Likewise, if you want to do a network camera, I'll go ahead and close that. If I click and drag, add a camera. And I think it was 57. Yeah. And that's all there is to it. So that's basically the camera. It's a very simple thing. You can, of course, rewind. So like before, if you use the scroll wheel, you can rewind. And of course, it's been sitting here just balancing, not doing a whole lot for a while. So there you go. And that actually kind of leads me to this bottom chart. I added a timeline chart. Here, let me close that. So another commonly requested feature, and one that I've wanted as well, of course, was a timeline, so you could very easily jump to different points in time. And so now you can just click to rewind in time. You can also click and drag, which can be good. So for example, yeah. So here we are, kind of like when I was recording the introduction you saw earlier. Another feature that people have been asking for is before, if you wanted to go back to the live view, you just had to scroll and wait and everything. And that gets kind of annoying, especially if you have a lot of data acquired. If you click this button, it will jump back to the end and you get your live data. And that is the timeline chart. Well, here, I'll just create one. So again, click and drag, pick the type, which would be timeline. You can have it show the timeline, which is this part at the bottom, and the time, which is here. Or if you want, you can have it just show the timeline or just show time. If you only want time, that might be useful if you have like a small chart, like maybe you had it like here, then you might just have it show the date and time. I'll use it to show both. If you are showing a timeline, you can use it to visualize Bitfields. So for example, this balancing robot has two boolean values that I send over telemetry. One of them is whether or not the robot is upright or if it fell over. Basically, if it fell over, I turn off the motors because I can't recover from that. And then the other boolean is if the integral component has saturated, that's not the best word, but if the integral component has reached the maximum value that I allow, that's often called integral windup, and that's kind of a fault, well, not a fault condition, but it's not an ideal condition to be in. And I added support for visualizing these. You've probably seen before where you can have tooltips on the charts. So for example, if you want to know when it fell over, you can click that, and it hasn't fell over. So let me make it fall over. I will, let's see, go forward. There we go, now it fell over. Good job. Okay, so now you can see that it has fallen over. And actually, let me pick it back up. All right, so if I rewind, let's see. We can see that it fell over here. So in case it isn't obvious, the right edge of your plot is basically the end of the moment in time you're looking at. And so this is the point in time that corresponds with the cameras. And of course, cameras often have a little bit of latency between when they acquire the image and then when it ends up at the computer. So yeah, there's a little bit of a latent delay there, but you can kind of see, and it fell over. And so on this chart, I have it configured to show those tooltips, and basically that's basically showing the edge. It can also be useful to show the level, so kind of like edge trigger or level trigger on a logic analyzer. But of course, this isn't triggering. It's just a way of showing your boolean or enum telemetry. And so, for example, if I want to know whenever it fell over, I can show it as a level like that, which can be useful. And I should probably show it down here, because that's really where you'd want to see the levels. So for example, if you were, there we go, back to live data. If you wanted to look at your old data and you're like, well, I wonder whenever it fell over, you can have it show the level in your timeline for fell over. And it'll be here. It's really small, so you can't see the rest of the text. It's cropped off. But if you click here, it will jump you to that moment in time where it fell over, and you can see here it fell over. So that was another feature I added, is I added the ability to visualize your Boolean and enum bit fields as a, well, I call it a level, but yeah, basically as just a marker over the entire duration. Whereas before you only could get tooltips of the changes, or the edges, if you want to call it that. And so that's what these icons demonstrate. These are basically edge triggered, or tooltips, if you want, probably a better way to say it. And then these are level triggered or just bars drawn on your charts. If you click on the icon next to the data set, it will it'll check or uncheck all of them. So if you have it show bars for both states, then it looks more like a logic analyzer where you have, it's up right here, which is right here at the end, and then it fell over here, and then it's back to upright here. All right, so this isn't really an ideal demonstration of that because I only have 2 Boolean values, but I think you get the idea. Unfortunately, a more advanced project that I'm working on I can't share with you right now, but it's really useful for visualizing fault conditions or things like that, where you might be sending a lot of data back to your computer and wanting to look at it, especially over, like if you do something overnight, it's really useful to have things you can click on so you can jump to the events. I'll go ahead and jump back to the live view, and just to keep it from getting too cluttered, I'll turn that off. Something else that people have been asking for, and of course I want as well, it was the ability to show time on the x-axis, and now you can do that for the time domain charts. So if you specify your duration as, for example, a number of seconds, minutes, hours, or days, then you can have the x-axis show the actual time. See here, or it can show time elapsed, which is what we had before. But time is often, a better choice. And if you go over to settings, you can choose if you want 24-hour time or AM, PM, and you can also choose if you want only time, or if you also want to see it as a date and time. So you can do something like that. And you can see here it'll show it both on the time domain chart and also on the timeline chart and on your tooltips. So you can kind of see here. There you go. Jumping around a little bit because the telemetry data is buffered with my Bluetooth UART sending data over, so a lot of the packets kind of get clumped together. I'm going to go back to only time to keep it simple. Another commonly requested thing was being able to edit your data structure after you define it. So before, if you called it accelerometer Z and you want to change that, you had to start over fresh, which is obviously very annoying. Now what you can do is you can just click on the data. So if you click on the label in the legend, or the label on here, you can edit that data set. So for example, gimbal X is steering. So why don't I give that a more useful name? And likewise, gimbal Y is throttle. So that is a small improvement. You can, of course, also change the color and give it a unit, or change the unit if you want. If you want to change other parts like the scaling factor, that unfortunately you cannot do when you're receiving data. So what you can do is, if you disconnect and then connect, so this is where you define your data structure when you originally connect. And if you want to edit, for example, the conversion ratio, what you have to do is you have to remove it and then add it again. And so, for example, well, let's say steering. If I want, I can go ahead and remove that. And by the way, you don't have to click all the way here. Like, you can just click anywhere on the row. Like if I just click here, it will ask if I want to remove that data set. And go ahead and click yes. One thing to keep in mind is Telemetry Viewer requires that every data set has data at the same moment in time. Like, you cannot have a data set missing data like in the middle. So if you remove a data set like we are now, you're going to lose all of your acquired data. In other words, you can't rewind anymore. and any charts that have this data set in it will be removed because it's basically going to create a new object and it's not going to relink it. Go ahead and click yes. And it removed it from the data structure, but it also put it back up here so that effectively I can edit it and put it back in. And so, yeah, it's a float. You can choose your other data types, of course, if you want, but it's a float. I'm going to leave it steering. I'm going to leave it the same color as before. And I don't actually need to change it, so I'm going to leave it the way it is. And just click Add. And now it's back. And go to Done. We can see here, it now reconnected. It's now drawing our data, but again, we don't have any of our old data because we removed a data set and it had to remove all of our old data to support that, at least for now. That's how I have to do it. And I removed this chart because it's a new data set technically, and so that old chart had to go. So I can go back and go to dial. And don't need that. And now we're back to normal. Something that is probably not visible in the video, but if you use it on a lower powered computer or if you're visualizing a lot of data, this version I actually spent a lot of time rewriting most of the code, and I was able to reduce CPU and GPU usage significantly. I also redid basically all of the OpenGL stuff, so now it's all shader based, and I was able to rework how anti-aliasing works, and that actually brought a massive, massive speed improvement. On Intel GPUs, it might be almost double what you had before, and on Nvidia GPUs, it can be literally 10 times faster, and I'll do a demonstration in a little bit to show you that. I was editing the video and realized I almost forgot to do the demonstration. So I'm recording this with my camera instead of screen capture just because when the CPU and GPU load is so high, it often skips out my audio. So I'll try version 0.6. And for the demonstration, I'll use the test mode. Create one big chart. And we'll visualize 3 data sets with 1 million samples from each. Oops. That was 100,000. I wanted 1 million. And I'll wait for those samples to be generated. Alright, so now we have a total of 3 million lines on screen. I'll go ahead and use the chart benchmarking feature to calculate the CPU and GPU usage. We can see that the CPU is at about 20 to 25 milliseconds per frame, and the GPU is about 170, 180 milliseconds per frame. Now let's try it with Telemetry Viewer version 0.7. Alright, so like before, we have 3 million lines being drawn on screen, and CPU usage is at about half of what it used to be. It's now below 10 milliseconds, and GPU usage is around 21 or 22 milliseconds per frame. So pretty drastic improvement. Also, something that I didn't show earlier is on this new version, the anti-aliasing is even though it's faster, it's better quality. Like, it looks perfect. You don't see aliasing on those thin edges. In version 0.6, there was a little bit of aliasing. It wasn't quite perfect. While working on improving the performance, I improved the cached mode of the time domain charts. So before, it was a separate chart type. You had time domain and you had time domain cached. But now it's just a checkbox. And so if you click that checkbox, it will now be in cached mode. And again, in this case, I'm nowhere near taxing my computer, so everything's working fine in both modes. As a demonstration of that cached mode where it can be really helpful, here we are back with the 3 million lines being drawn on screen, and we can see here that when cached mode is disabled, we're using about 9.5, 10 milliseconds of CPU and about 33 milliseconds of GPU time. If I go to cached, you can see it's like a fraction of a millisecond for the CPU and only a couple milliseconds for the GPU. So that can be really helpful if you need to plot massive amounts of data, or if you're on a laptop and you want to save your battery life, or just not get burned from your hot laptop. Cached mode can be a lot faster because it's basically only drawing a delta. So like whatever it needs to redraw for this frame, it will redraw that. Another improvement that I made that is not obvious is before it would not work in Java 9 and newer, and I was able to update some libraries and work around some bugs or undesirable behavior, and I got it to work correctly now in Java 9, 10, 11, 12, and so on, all the newer versions of Java. Another kind of small thing that I did to make things a little more easy to use is when you're adding a chart, now the chart type is just a button, so you don't have to click on a drop-down box. It's now one click instead of two. A minor thing, but it's just a small change I made to help try to speed things up when you're working. All right, in the previous version, the bottom left corner of the window was a little bit cluttered, and I decided to clean it up and just keep it as settings, import, export, and help. And so now if you click export, it will have a pop-up window that will let you pick what you want to export. What used to be called the layout file, I renamed to the settings file. It's the same thing, I just felt like layout file was kind of confusing people, and settings file does a better job of describing what it actually is. And then of course you have your CSV file, which is your acquired samples, like all this data here and here and here. And now that we have, of course, cameras, you can export those as well. And so if I go ahead and do export, let's make a new folder. Test, export. And you just give it a name. I'll say demo, and then save. And there's a progress bar up top that just finished pretty quickly because we don't have a lot of data yet. If I go ahead and all right, so basically we have a whole bunch of files here, and I'll explain what it is. So the txt file is the settings file, or layout file as it used to be called. The CSV is your acquired samples, just like before. Probably want to look at this in Excel, not Notepad, but you get the idea. And then the videos are, each video stream is 2 files, and you need both. So MJPEG is basically all of the frames as JPEG images and are just concatenated into one file. The bin file is basically an index for that, which contains the timestamps for each frame and where in the MJPEG file it's located. In the future, I plan to combine these into something standard like a regular video file, an MP4 or an MKV or something. But I haven't had time to figure that out, so for now it's 2 files. And so if you want to import it, you can just go to import, and you just pick whatever you want to import. So if you just want to import your layout file, it'll acquire all new data, so it'll connect and it'll start capturing new data. So this is all live data. If you want to import what you actually saved and rewatch those videos and the data and all that, you can select everything and go to open. Now it's actually importing the old data. So this is the saved data from a while ago. It will import in real time, like play back in real time like before. And again, you can see a progress bar up here showing basically where you are in the file. As always, you can rewind and go back. We'll go back to live view. Like before, you can click finish to just import the file and not play it back in real time. And there you go. something that is not so obvious, but I will try to demonstrate, is if I click finish, it will try to import the file as quickly as possible. But if you're importing a very, very large file, it might take 10 or 20 minutes to do that. And before you had to wait, you couldn't cancel an import. Well, now you can. So if you click again, it'll change names to abort. Then you can cancel the import. And yeah, it happened so quickly you couldn't see it. That sums up basically the new features in this version. And what I'll do now is demonstrate how to use it from start to end. All right, so if you want, you can check out my earlier videos where I show all the details of how to wire up an Arduino, how it all works, but I'll do a kind of a quick demonstration again for people that haven't seen my earlier videos. So when you're sending data, there's two ways. You can send it as CSVs, which are comma-separated values, in other words, text, or you can send binary, which is a lot more efficient, like you can use a DMA transfer to just send it over. But that's kind of more advanced. So first I'll show comma-separated values. You pick that. If you know approximately how many telemetry packets per second you're sending, you can type this in. If you don't know, you can just give a rough estimate. This is mainly important when you're using a frequency domain chart or like an FFT, because this is going to determine how the sample numbers and frequencies correspond. So if you get this wrong and you do a frequency domain chart, your frequencies are going to be off. Anyway, so I'm going to say, okay, maybe roughly 100 times per second I send telemetry to the computer. And then you pick your COM port, and I think COM3 is an Arduino, but I'm not sure. Let's find out. And then you pick your baud rate. Why is that not? There we go. Yeah, so you pick your port here. If you have any COM ports, they'll be here. And then you can also start a TCP server or UDP server. I cover those in more detail in my earlier videos, but yeah, it's all pretty simple. And then test is a little demonstration mode, which I'll show in a little bit. But yeah, you pick your COM port, you pick your baud rate, click connect. Before it was a pop-up window, but now it's just going to be in the main window. So there's one less window jumping up and cluttering your screen. This is where you define your data structure. So we're doing CSVs, and so you have a column number. The first one is column 0, and that would be whatever it is you're sending. Maybe it's I don't know, battery, voltage, and then you can pick a color. You can give it a unit, let's say millivolts. And you can have a scaling factor. So maybe 4095 corresponds with 3.3 volts. And then you click add. And you can add more columns, so it automatically increments the column number. And maybe your next thing is, I don't know, a temperature. And again, you pick a color, give it a unit, and some conversion factor. Usually you wouldn't do this for temperature, but whatever, you get the idea. And that's all there is to it, so you just keep adding that. Down here I have example firmware, and so you can use this as a template for the Arduino. And obviously you need to edit this and put your data here. Choose how long you want to delay between telemetry packets, and if you want to use floating point numbers, use this instead. And then you click done when you're done. And so right now it's connected to the COM port, but it is not seeing any telemetry. So it's telling you to send telemetry. And that's because I just connected to a random COM port and there's no telemetry coming. But anyway, if you add telemetry, you can click and drag to add a chart, and then pick whatever you want to show there, adjust your settings, create another chart, and so on. a lot of the charts won't show up if you don't have any data. So like you can't have a histogram of 0 values, so there's no plot. That's why it's empty. And the timeline, of course, has nothing as well. So you kind of get the idea. Let's take a look at binary mode. So I'm going to go ahead and redo everything I did to get to the balancing robot, so I can show how everything works. So in that case, I have it set to binary. Just from testing, I realized that I'm sending telemetry about 73 times per second. The robot is using COM port 6 for the Bluetooth UART. You probably saw earlier where I clicked the drop-down box and it was like hidden. That has to do with how the OpenGL stuff is drawn and it's overlaid on top, and sometimes it happens, sometimes it doesn't. I don't know if there's a workaround for that. I haven't found one, but basically if you just unmaximize and remaximize, usually that'll fix the problem for you. And then the baud rate, pick that. All right, so the balancing robot has a lot of telemetry. I'm going to go ahead and just type it all out and fast forward the video for you guys. All right, so one thing I'm not sure if I've shown in detail before is Bitfields. So I currently support just one type, which is a 1-byte Bitfield. You give it a name, you give it a color if you want. Here, I'll pick green. There's no unit and no conversion factor because that wouldn't make sense for a boolean or enum. Click add, and then you can define the bit fields. So I just have 2 booleans, so I'd click on bit 0, and then you can have each bit, you can give it its own color. In my case, bit 0, if it is 0, would be upright, and if bit 0 is 1, that would mean it fell over. Oops. There we go. And so upright is fine, I'll leave that green, and for fell over, I'd consider that like a warning or a fault, so maybe I'll make that red. And then my other boolean is bit 1, so I click here. If you have an enum where you have like more than 2 choices, you can click and drag, but I only have a boolean, so I'm just going to click and let go. And if bit 1 is 0, that would mean that I don't have integral windup, which is good. And again, integral windup, I wouldn't consider that an error, but maybe a warning, so I'll give it a yellow color. And then if you have any others to define, you would define them. I only have 2 booleans, so that's it. And you can click done with Bitfield. I don't have any other fields in my data structure other than a checksum. So I go to checksum, and my checksum is at location 113, which is the 114th byte. So basically, it looks at bytes number 1 through 112. All right, hopefully I typed that all out and had my notes correct. Let's find out. Let's see if let's try this. That looks about right. Yeah, so I didn't get the colors quite right, but you can kind of see how everything's working. We can put the camera back. And let's see, where did the robot go? Oh. There we go. And we can add the other camera back. I think it was 57. Yeah. Why is it blurry? All right, that's better. So yeah. Anyway, you get the idea. Now you kind of know how it all works. Oh yeah, so how do you actually use your old smartphone as a webcam? So there is a free app, at least for Android, probably for the iPhone as well, called IP Webcam. And I'm guessing that one's it. Yeah, by Pavel, probably mispronouncing that, sorry. But yeah, this is the app that I have installed and I use it. One thing to keep in mind is if you're using an older phone, or even on a newer phone, if you're streaming for a long period of time, your phone's going to get hot because it isn't really meant to be recording video for hours on end. And there are settings, if you go through the settings, to limit your frames per second, which is what I have. I limited it to about 12 or 15 on my old Note 5 smartphone. On my newer phone, like a Note 10, I can actually stream 4K video at 30 frames per second, and it doesn't seem to mind too much. It can keep doing that for quite a long time. All right, so that about sums up the new features and kind of a brief introduction of how to use the software if you haven't seen my earlier videos. If you haven't, I would recommend that you watch my earlier videos where I go into more depth on how to use the software and how to wire up an Arduino if you need that information. I'll have links to that in the video description and also on the website. So finally, we can get to the Raspberry Pi 4. For the Raspberry Pi demonstration, I don't think it's going to be powerful enough to do a screen capture, so I'm just going to aim the camera at my monitor. Alright, so I am using the Ubuntu, I think it's 2004 image for the Raspberry Pi, and that's actually something very important. Telemetry Viewer requires geometry shaders, which are part of OpenGL ES 3.2. The Mesa driver for Linux for that GPU on the Raspberry Pi 4 only supports OpenGL ES 3.1 right now. The version of Mesa that is included with Raspberry Pi OS does not support geometry shaders. However, the version that is included with Ubuntu does. And so I recommend that you use the Ubuntu image for the Raspberry Pi 4 because it'll just work. It's easy. If you want to use it on the Raspberry Pi OS, I'll have some information on my webpage detailing the commands you need to basically download the source code, recompile Mesa, install it, and then how to use it. But yeah, it's a lot easier on Ubuntu, so I would recommend you try that if you can. And so I have the file on my USB memory stick. So on Ubuntu, if you just double-click the file, by default it'll open it up like an archive. That's not what you want. You can right-click and go to Open with OpenJDK Java 11, or you can go to Open with Other Application, and have it remember, which is probably what you want to do. So make sure this is checked. Okay, so in that case, let me remove the old version. I'm going to copy it from my USB memory stick onto my actual computer. And now I can right-click, go to Properties, Permissions, and Allow Executing. Close. All right, and so now it opens up, and it's just like before for the most part. So I don't actually have my Bluetooth UART bound to the Raspberry Pi, so I'm not going to try demonstrating the robot, but I'll just go ahead and show it in the demo mode, or test mode you might call it. And so I'll go ahead and connect. All right, so now we have, this is like the demo mode, so there's some like fake telemetry being sent automatically. And like usual, you click and drag to create a chart, and you pick whatever you want to show. Anyway, so you get the idea, and you can, have more data. There's a couple things to keep in mind. Right now on the it only works on the Raspberry Pi 4, and that's because I really needed the geometry shaders to make everything work. Without it, it's just really slow. I am looking into ways to make it work on the older Raspberry Pis, but I have a feeling it's not going to be worth the effort. So I'm going to look into it more, but for now, I'm really only expecting to support the Raspberry Pi 4. Also, the camera does not currently work. I need to figure out, there's some issues with the libraries that I use for accessing webcams, and they don't quite work on the Raspberry Pi. It looks like there's workarounds, and I'm looking into that, but I haven't been able to figure it all out yet. So for now, it doesn't work. Sorry. I recommend you not click the camera button, because if you do, the program will crash. In case you do, I'll show you how to recover. So if you click camera, it'll like not work, and you won't be able to close even. Like it just stops responding. Like if you try to resize the window, it won't work. And unfortunately, okay, well, that's good. Half the time when I try this, the rest of the user interface won't work. So that's good. If you find where everything's locked up and you can't do anything, on your keyboard, do Control-Alt-F1. This is it's because I've got a 4K monitor, so it's really small. It'll ask you to log in, so you type in your username and password. Yeah, so you log in, and then you can type in, here, I'll type it out. You type out kill all -9 Java, so KILLALL-9 JAVA, and press enter. That basically forces Linux to close Java. And then you can do Control-Alt-F7, and now you can actually use your computer. Let me open it back up. The only other limitation right now is anti-aliasing is disabled. So it may not be super obvious in the video, but there is lots of aliasing. It is actually, the OpenGL ES on the Raspberry Pi does support anti-aliasing. However, when I render to off-screen frame buffers for some of the functionality that I need, it doesn't do anti-aliasing. And I'm looking into workarounds. I actually found one I think is going to work, but I haven't had time to test it yet. So for now, if you go to settings, if you're on the Raspberry Pi or anything else with OpenGL ES, it will default to anti-aliasing level 1, which is no anti-aliasing. If you try to turn it on, it will turn on and turn back off. And the program will continue to run, but if you're running this in a command line, you will see an exception printed out to your terminal. But the program does continue to run. It just, it won't have anti-aliasing. All right, so that's basically all there is to show for the Raspberry Pi. One last thing to keep in mind is the Raspberry Pi is a little single board computer, and especially on the Pi 4, which you can't quite see, if you don't have a heatsink installed, like right now I do not, it will get very warm. So right now we're at about 83 degrees, which is not good. So you may want to install a heatsink if you plan to use Telemetry Viewer for a long period of time. If not, then your CPU will throttle down, and of course your frame rate might drop a little bit. One last thing I don't think I mentioned in the video for beginners is there's a help button which will give you a little bit of information if you ever forget how to do certain things. Alright, I'll have a link to the software in the video description. It's also right here. And if you did find the software useful, and if you'd like to, send a little money my way, that would always be welcome. I've had a few people send a little bit, and I do appreciate it. It helps kind of motivate me to continue developing the software. Anyway, don't worry. There's nothing nagging in the software. It's not going to beg you for money. There's just a link right here. All right. I hope you found the video interesting. If you know anybody that might benefit from the video, please share a link with them. If you have any questions or comments, leave them down below.